Good evening all. Myself Uma Mahesh. I welcome you all on behalf of ACE Engineering Academy to the preparation strategy for the subject Strength of Materials, which is the common subject for three branches including Mechanical Engineering, Civil Engineering, Production and Industrial Engineering. Strength of material, this is one of the most fundamental and basic subjects. This subject, it is giving the platform for many subjects related to the design aspects. That's why our experts are giving a more priority and importance for this subject for various examinations. Now, in this particular session, what we are going to be discussed is, we are going to be start our discussion. First, let us try observe the syllabus and pattern that we are having related to the subject for GATE examination as well as engineering service examination. After understanding the syllabus pattern for the subject for GATE as well as engineering service examination, now we try to focus the weightage that we are having related to this particular subject for the three streams like civil engineering, mechanical engineering as well as production and industrial engineering. After we are focusing on the weightage of this subject, now our target is chapter-wise weightage related to the each chapter. By observing the weightage of each chapter, then we are deciding, we are giving some sequence of importance for various subjects. By observing the sequence of importance for various topics, then we can understand where we need to pay the more attention, where we are having a little bit of attention is required for related to that particular topics. And last, we are focusing on some reference books that are available for enhancing our subject skills related to this particular subject. Now, I am going to first take the syllabus pattern. First of all, I am taking the mechanical branch and we try to observe the syllabus related to the subject related to the mechanical branch. As far as GATE is concerned, the technical subjects we are dividing into three categories. First category, applied mechanics and design part. Second category, fluid mechanics and thermal sciences. And the third category, materials and manufacturing and industrial engineering. These are the three areas we are observing related to the technical subjects for mechanical stream. Our subject, if you are observing, our subject is, categorized under this part. First subject we are having engineering mechanics. Second subject under this category we are having mechanics of materials. Strength of material is known as mechanics of materials. And after that we are having another subject, mission design. Then we are having theory of missions and vibrations. In this stream, so our focus is preparation strategy for this subject. Basically, engineering mechanics is parent subject for strength of material. And when we are dealing with the mission design, some of the applications would definitely be required from the strength of material subject. That's why strength of material, as far as the design is concerned, this we may consider as the basic and the fundamental subjects. So some of the topics we are using in strength of material related to the mechanics, if you take, for an example, finding the support reactions and using the free body diagrams or using the equilibrium conditions and finding the moment of inertia and finding the centroid. These are the some concepts definitely we are applying when we are learning the mechanics of materials. In the similar manner, by knowing the strength of material only, we are able to or confidently design the variation mission elements. So, as far as mission design is concerned, without knowledge from the strength of material, we are unable to make the subject mission design. And come down to the syllabus. When we are moving to the syllabus of this particular subject, now these are the various topics we are observing from this particular subject. Look at the first one, the concept of simple stresses and strains. See, every subject when we are learning, the first topic is related to the fundamental concepts. In general, in first topic, we are dealing with the parameters that are related to the particular subjects. For example, if you take the engineering mechanics, in first topic, we are dealing with the force and moment system. Their force and moment, we are always dealing with the parameters in that particular subjects, force and moment system and their effects. Another example, if you take fluid mechanics. In fluid mechanics, first topic start with the concept of properties of the fluids, which are useful for studying the entire subject. In the similar manner, when we are studying about the strength of material, the subject strength of material completely revolving around two parameters, that is the concept of stress and the concept of strain and the relation between these two parameters. In this particular topic, we should clearly understand what is the stress and what is the strain, how it is the stress and strains are developed in the members, how we can calculate the stress, and how should we find out the stress at one point, how we can define the stress at one point, what is the physical significance of doing the stress analysis related to the design aspect. Similarly, what is the strain and how you define the strain, how many types of strains we are observing, how you are defining the strain at one point, and what is the fundamental relation between the stress and the strain, why we are using this relation, and some simple loads we are applying. We try to find out some deformations under that simple loading conditions. That all the things we are going to be discussed in this particular topic. This is very lengthy and concept-based topics. That's why from the examination point also, this topic it is having a very high weightage and very important, because many concepts we are going to be derived in this particular topic. That concepts we can reuse them for the coming topics. The next area, if you take this one, the analysis of thermal stresses in the members. See, in first topic, our concentration is when we are applying some mechanical loads, like axial loads or shear loads, what are the corresponding stresses and strains are generated in the member, how should we find out them? But in this particular topic, I can say it is an extension for the first topic. When we are doing some temperature changes for the member, how the corresponding stresses and strains are generated, how should we find out the corresponding stresses and strains because of temperature changes. The stress or the strain generated because of doing some temperature changes, we may call it as a thermal stress. So this stress we may consider as the secondary stress, and the stress that is developed because of mechanical loads we may consider as a primary stress. Now in this topic, our focus is completely related to the stresses because of some temperature changes. And the next topic is very important topic related to the practical conditions, because in practical scenario, if you take some examples like if you take the dams, if you take the retaining walls, if you take the chimneys, if you take the shafts, if you take the turbine blades, if you take the aeroplane wings, in all these examples, if you are observing, the members are subjected to the multiple loading conditions. That means the simple loads are simultaneously acting on the members. When the loads are under multiple conditions, such condition we may call it as a compound loading condition. That compound loading, it is giving the complex state of stress. Whenever the member is under a complex state of stress, from the design aspect, what is your approach? How you are making the design for such members? Whenever the member under combined loading condition, the design of the member should be based on the concept of principal stresses and principal strains. So in this particular topic, our objective is identifying the planes which are carrying the principal stresses, identifying the planes which are carrying the maximum shear stress, identifying the planes which are carrying the maximum shear stress, and the magnitude of, finding the magnitude of a maximum shear stress. These parameters we are involving for designing the members under combined loading conditions. But here our restriction related to this particular topic is that concepts we are going to be derived for plane problems, two-dimensional problems, not for a three-dimensional problem. This topic is a very important, not only from the examination point. Yeah, so from the design aspect also, if you take the real life conditions, most of the applications when we are designing, we are assuming in this condition. For example, as I said, many examples, shaft design, beam design, slab design. Many examples we are having, dam design, thin pressure vessels design. So many of the examples when we are taking, they are all categorized under a plane stress or a plane strain condition. Then the another topic, if you are taking this one, this is another most important topic from the examination point, the concept of shear force diagrams and bending moment diagrams. What exactly the shear force? What exactly the bending moment? First of all, how you are defining the beam? These things, what is the physical significance of shear force diagrams as well as bending moment diagrams? When we are making the design of a beam based on a strength criteria, the things we are going to be discussed. In addition to that, what is the relation between applied loading conditions, the developed shear force and a developed bending moment? How should we use that relations to get the shear force or bending moment at a particular location? That things we are going to be discussed in this particular topic. After that, our focus is analysis of bending stresses as well as analysis of shear stresses in beams. As we know, the developed bending moment in a beam, it is giving the bending stress. Under what conditions or under what assumptions we are analyzing the bending stresses. Similarly, the developed shear force in the beam, it is giving the shear stresses. So under what assumptions we are analyzing the shear stresses. When we are making the design of the beam based on strength criteria, for which parameter we are giving the importance, either the design of the beam based on bending stresses or the design of the beam based on shear stresses. Why we are making the design of the beam based on bending stress analysis? Why not shear stress analysis? That things thoroughly we are covering in this particular topic. After that, now let us take the another area. Now the concept of torsion. Torsion, it is one kind of deformation that we are observing on any member when I try to give the equal and opposite moment about the longitudinal axis. When the member is under torsion, some kind of stresses are generated to resist that torsional effect. That stresses we may call it as a torsional shear stresses. How should we analyze the torsional shear stresses for the case of circular members? In our syllabus, you are having a circular objects only. Why, when the member is under twisting condition, why we preferred a circular shape? Why not other shapes? That things we are going to be discussed in this particular topic. And the next one, if you take this one, slopes and deflection, this is an extension for these topics only, my dear friends. So whenever the beam is loaded, it is getting into the deformed condition. When the beam is under deformed condition, the longitudinal axis of the beam, it is deviated under two ways. One, linear deviation, what we call it as a deflection. The second one is angular deviation, what we call it as a slope. In this particular topic, our objective is finding the maximum slope and the maximum deflection for various beams under different loading conditions. So why we need to determine the slopes and deflections? Sometimes our designed member may satisfy the strength criteria, but unfortunately it is going to be failed because of stiffness criteria. So whatever the member we are going to be designed, definitely that is going to be satisfied both strength as well as stiffness criteria. So to avoid the failure related to the stiffness criteria, we try to find the developed slopes and deflections where it is having the maximum values for various beams under different loading conditions we try to observe in this particular topic. After that, so we try to, if the column is having the buckling mode of failure, buckling, it is one type of failure condition that we are observing frequently in case of long columns, or what we call it as slender columns. So when the column is, it is going to be fail in terms of buckling mode. What are the various theories are available for us? to estimate the safe load on the column. And when the column is under eccentric loading condition, what is our design approach? What are the important aspects we are considering while we are making the design of the column under eccentric loading conditions? That things we are going to be discussed in this particular topic. After that, our focus is related to the concept of strain energy and resilience. Yes, the concept of strain energy and resilience generally we are using in the application of slopes and deflections in case of beams, right? To estimate how much load I can permit on the column based on the absorption capacity of the energy. So for doing that, we are analyzing the concept of strain energy as well as resilience. So what is strain energy? What is resilience? What is the basic difference between resilience, modulus of resilience, toughness? All these things we are going to be discussed in this particular topic. After that, so we try to focus on the physical significance of the point of a shear center. What is a shear center? What is its physical significance? Why we require to locate the shear center, particularly when we are doing the design related to the thin-walled sections. That things we are going to be discussed in this particular topic. And at last, this topic is recently added for mechanical testing of mechanical properties for various materials like tensile test, hardness test, various impact test. This is basically this topic is related to the first topic only we are having. My dear friends, this is the brief syllabus we are having related to the mechanical gate people. So more or less for civil people also almost the same syllabus we are having, more or less. The concepts what we are having related to the civil pattern, civil branch if you take, again the technical subjects in civil branch are divided into 6 areas: structural engineering, geotechnical engineering, water resource engineering, environmental engineering, transportation engineering, geomatics engineering. Our subject named under this category, my dear friends, structural engineering. So our subject named as a solid mechanics for civil people. And again, the concept of solid mechanics we are going to be used. This is very useful when we are analyzing the structural analysis, when we are analyzing the steel structures. The application of solid mechanics we are going to be applied in these 2 subjects. Some other subjects also there, but I am not insisting them. So definitely some basic knowledge from this subject is essential for analyzing or for observing or for studying the other 2 subjects like structural analysis and steel structures. And let us take the syllabus, topic-wise syllabus if you are observing as we discussed. First topic start with the concept of simple stress and simple strains, and then after we are dealing with the thermal stresses. After that we try to focus on the stress and strain transformation equations, what we call it as a plane stress condition and a plane strain condition analysis. And after that we try to observe the shear force diagrams as well as bending moment diagrams for different beams under various loading conditions. By doing this analysis, we try to analyze the corresponding bending stresses as well as shear stresses in beams. After that, we will focus on the concept of torsion as well as deflection in beams. After that, columns, then energy methods and shear center. This is the topics that we are going to be covered. And one more topic we are having, that is propped cantilevers and fixed beams. But the scope for the propped cantilevers and fixed beams is limited related to the strength of material. The same concepts, the same topic you are going to be studying in SA. And come down to the next pattern. Yes, look at this one. When I am talking about the production and industrial engineering, yes, here also these technical subjects are dividing into various categories. First one is general engineering. Second part is manufacturing process 1. Third part is manufacturing process 2. After that, industrial engineering. Next one is quality and reliability conditions. After that, operational research and operational management systems. Our subject is categorized under this part, general engineering status. So in general engineering status, these are the various subjects we are having. Our strength of material is related to this particular subject, applied mechanics. Applied mechanics. Now, as far as syllabus is concerned, this one. So, first one is the concept of stress and strain. This is the most fundamental topic. Whether if you are mechanical, if you are civil, or whether if you are production, whatever it may be, the subject starts with the concept of stress and strain, the most fundamental subject. After that, this is more circle of stress is related to the concept of principal stresses and strains. Once we find out the principal stresses and strains for the member under combined loading condition, so by using various theories, various failure theories like Rankine's theory, Tresca failure theory, Saint-Venant's theory, von Mises theory, like that we are having various theories. So that theories we are going to be used to predict the failure condition when the member is under combined loading condition. So basically, this failure theories topic is an extension for the concept of principal stresses and strains what we are studied in this area. How we are using such theories to predict the failure of various materials under combined loading condition. That things we are going to be discussed at here. After that, the concept of bending and shear stresses. As we know, bending moment, developed bending moment in the beam, it is giving the bending stresses, and a developed shear force in the beam, it is giving the shear stress. How should we analyze these two stresses? That are going to be discussed in this particular topic. After that, so we try to focus on the deflection of beams. See, for production engineering, we are maximum cases, if you are having the problem from this topic, it is coming from standard cases only. We are having almost 6 standard cases, 4 from cantilevers, 2 from simply supported beams. Most of the times the question from those standard cases only. After that, again, the concept of columns, Euler theory related to the buckling mode of failure, how we are using this theory to predict or to provide the safe load on the column. After that, the next topic is the concept of thin and thick cylinders, then the torsion. These are the various topics that we are going to be covered related to the production and industrial engineering. So this is the overall syllabus that we are using, that we are going to be observed for these 3 streams, my dear friends. More or less, almost all are having similar topics, my dear friends. But if you take this one, so small reduction we are observing for the syllabus related to the production engineering. Now, come down to the weightage of this particular subject for mechanical, civil, and production engineering people. So if you take a last 4 years session also, set 1 and set 2 if you are considering, on an average for mechanical people, the weightage for this subject, if you take 8 to 10 marks, we can expect, my dear friends, for mechanical people on an average. And for civil, if you are taking, it is 4 to 6. By looking at this figure, don't be underestimate this subject. So it is giving a less priority. So why we need to study this subject like that? You don't think about this subject, because even though it is having a less weightage, but when we are studying about the steel structures or structural analysis, without using the basic concepts from this subject, we are unable to study those subjects. Definitely, to study those subjects, we require the basic knowledge from this subject. Indirectly, this subject is helping to analyze the other 2 subjects. So definitely, that is one of the reason we need to give the more priority for this subject, civil people also. And as far as production is concerned, we can expect 5 to 6 marks. Generally, 1 mark question 1 or 2, 2 marks question 1 or 2. In general, they are having production people. So this is the gate weightage for this 3 streams, my dear friends. And come down to the chapter-wise weightage. Once we know the chapter-wise weightage, then we should understand which topics we are giving more importance, or we need to pay the more attention, at what areas we are having a little bit of attention is required, that we can realize. See, just I'm taking the couple of year papers and we try to just short listed these things, chapter and percentage of questions asked in the previous examinations. As I told you, first chapter, it is very, very important, my dear friends. Simple stresses and strains. Now look at here, for engineering, for mechanical engineering people, 24% it is given. Almost I am taking 15 years papers, from that we are analyzing this. And for civil, it is a 20%, and for production people, it is 18%. That means this is very, very, very important topic, not only for gate, it is also important for ESC also, for all streams. After that, look at this one, plane stress and plane strain condition. These are the figures we are going to be observed for mechanical as well as civil and production people. And after that, shear force and bending moment diagrams, if you are observing, this is the percentage we are observing. And similarly, if you are observing the bending and shear stresses, yes, this is the percentage we are observing, 9, almost equal. And this is 5 we are having. And slopes and deflection, see the importance of slopes and deflection topic for the civil people. 30% we are observing it here. For mechanical people also, it is one of the important topic. And for production, as I told you, the questions are coming from the standard cases only. There is no difficulty in this particular thing. And as far as torsion is concerned, torsion topic is very important for mechanical people. Frequently, we are having the problems from this particular topic rather than civil and production people. And thin cylinders, another area. Recently, we are having the numericals from the thin cylinders. Previous, we are giving the less importance for this topic. Nowadays, the trends are going to be changed. And the next one is columns. See the figures related to the columns. Columns, strain energy and resilience. And this topic was not there for production engineering. And mechanical testing of materials only we are having, mechanical people are having. No, there is, yes, it is not having for civil people we are having. Like that we are having some other, based on this weightage what we are observing, just you can give the sequence of importance for various topics, mechanical, civil, as well as production people. See, as I told you, this is the heart for entire subject. So we are giving the more priority for this subject. Stress and strain relation. After that, plane stress condition and plane strain condition. Mechanical people never leave these topics when you are preparing these subjects. I mean to say, no, other topics are not important. I don't say like that. So this is the first priority we are giving. These are the topics we need to give the first priority, right? Out of all the topics. And thin cylinders, shear force and bending moment diagrams, and slopes and deflections. Apart from that, so I'm not writing the thermal stresses, and the thermal stresses also comes under this category. That's why I'm not writing it here. And these are the topics the mechanical people never going to be leave while they are preparing for the gate examination. And as we move forward to the civil people, now look at, these are the various topics the civil people never leave when they are preparing for the gate examination. Stress and strain relations, complex stresses and strains, slopes and deflections, shear force and bending moment diagrams, in addition to that, columns. Frequently, the questions are coming from the columns, particularly for the civil people in this particular gate examination. And as we move on to the production engineering people, don't leave these 4 topics. The concept of stress and strain, the concept of principal stresses and strains, slopes and deflections, and the columns. Frequently, we are having the numericals from these topics, so particularly for production engineering people. Right? Now, as far as ESC is concerned, engineering service examination is concerned, more or less all topics what we are preparing for the gate examination help you in writing the ESC examinations. Now look at the syllabus pattern for mechanical stream. Almost same syllabus we are having. Simple stresses and strain, thermal stresses, plane stresses and plane strain conditions, shear force and bending moment diagrams in beams, bending and shear stresses we are having, torsion, concept of torsion. deflection in beams, columns and struts, strain energy. So this is additionally we are having springs. Additionally, this topic we are additionally having for mechanical springs topic. In the springs also, most probably questions are coming from close coiled helical springs. Close coiled helical springs under axial loading conditions. And pressure vessels, thin and thick pressure vessels. Now, when you take the civil, yes, in civil also, yes, this is additional topic we are having when compared to the gate and shear center, the concept of shear center, and additional topic is theories of elastic failure is added here for civil people. And these are the additional topics we are observing for ESC compared to the gate examination. And when you are taking the ESC questions, and particularly just I am taking a prelims for mechanical, on an average, if you are taking a last couple of years from 2017 to up to 2022, on an average we are having 12 to 13 questions on an average. On an average 12 to 13 questions. See, in 2017 we are having 11 questions, 18 it is 8, and again in 19 trends are different, yes. 15 questions we are having. In 2020 we are having 11 questions, 21 and 22 almost same level. 9 questions we are having. But whereas if you take mechanical, civil, in 2017, 21 questions from this subject, so it's very good weightage. And in 18 it is 16 questions we are having. In 19, 20 questions again. In 20 we are having 18 questions. And 21 we are having 15 questions. In 22 again we are having 18 questions. On an average again, if you observe these trends, for ESC prelims, more or less we are having 18 to 20 questions on an average from this particular subject. 18 to 20 subjects from one single subject. See how we are giving the importance for this subject, not only for the gate examination, for ESC examination also. So after observing the weightage, our focus is preparation strategy. This is main thing what we are having related to this session. How we start preparation for this subject, whether it is a gate examination or whether it is a ESC examination or else any other competitive examination. See, as the experts are giving more importance for this subject and they are giving a good weightage for various competitive examinations for this subject, if you plan this subject in a systematic manner, we are able to answer most of all questions from this subject. Why I am saying this one is, the most of the questions we are having from this subject is almost 80%, 80 to 85% of the questions are completely numerical based questions from this subject. So when you focus on how you are applying the concept to get the numericals, when you are solving the numericals, then automatically you are able to solve all questions from this subject. So what is the pattern I am going to be suggested to learn this subject, particularly competitive examination field is, now this is very important. Carefully you can listen the lectures from the faculty. For this you required definitely patience you can require. So a little bit attention is required. Each and every point and each and every topic you try to listen carefully. Then from this particular classes, after listening the classes, try to focus on some important concepts, some important formulas, some important relations related to that particular topic and address them separately in one particular handbook. Whenever you are free, you just go through this handbook, what you wrote related to the relations, formulae and some important points, just you go through them. If you do it continuously, that concepts, that relations are completely feed in your mind. This is the best learning approach. After doing that, yes, when you are, yes, take the classroom notes and handbook and try to observe. See, this is very important thing. Wide and extensive study is required for the objective type questions. Don't go through the concepts blindly. Try to understand each and every corner of the particular topic. That's why I'm using the word extensive. So when you try to understand each and every corner of each topic, then you are able to ready to apply the concepts in solving the objective type questions, because we are having most of the times we are having the MCQ questions. So with the MCQ questions we are having the advantages as well as disadvantages. Suppose if you know the concept, we can easily eliminate the options which are not related to the given question. Suppose if you are poor in concept, then that 4 options are giving lot of confusion. Which one is correct? Which one is correct? You are in the dilemma mode. So you are unable to answer that particular question. So to avoid that confusion, so you require the wide and extensive study for each and every topic, so that we are confidently eliminate the unrelated options without doing the calculation part. Then after doing this, try to once again you can solve the classroom examples what we are discussed in the classroom session. Again, without any deviation, you try to solve them. Suppose when you try to solve them, then you can identify where you are lagging, where you are strengthening the subject, so that accordingly your strategy and plan is going to be changed. After solving the classroom examples, try to solve the previous year gate questions by applying the concepts. Try to solve previous year gate questions by applying the concepts. Once you did this one, then you can take a chapter-wise test and subject-wise test. Here, ACE Engineering Academy provides the chapter-wise test as well as subject-wise test. So once you appear for the chapter-wise as well as the subject-wise test, then you can realize where your strength or what is your strength, what is your weakness related to that particular subject. Suppose you are unable to solve the question within the stipulated time, then you can think about that, where you are doing the mistake. You try to overcome that areas. So appearing the chapter-wise test and subject-wise test help you lot related to the, yes, subject-wise improvement. Once you come across this area, then yes, our engineering provide the volume 1, volume 2 books, bits and byte books. You try to solve the question from that books. Generally, if you take the volume 1, volume 2 bits and bytes, the questions that we are framing, particularly I'm speaking about the our academy books, the level of difficulty is somewhat slightly more than gate level. So that slowly, once you complete all these 3 areas, then while you are solving these questions, you are having lot of confidence. That means where we are applying the concept, what is the logic in the given problem, you can easily crack it. So these thorough knowledge helping us to overcome the difficulties that we are facing in the problems related to volume 1, volume 2 as well as bits and bytes. So after that, try to attend full length test, so that overall performance you can identify it easily related to that particular subject. What is your performance related to that particular subject? Even though if you are scoring less marks, need not be degrade yourself. So that will help you to strengthening the subject, right? Now after that, you try to attend the mock test series. Then you are having one conclusion. If you follow this pattern, you are having one conclusion related to this particular subject, right? But as far as the ESC preparation strategy is concerned, so what is the difficulty we are facing in ESC prelims is, whatever the questions we are having, most probably they are numerical based questions, but unfortunately calculator is not allowed for solving that problems. Otherwise, we can easily solve that questions. So for that, how you are overcoming that difficulties, first try to focus on ESC previous year questions. Why we need to first focus on ES previous year questions is, most of the times if you are observing every year pattern, most of the times more than 50% of the questions that we are getting for ESC prelims, more or less, they are using the similar concepts. Whatever the concepts we are having in previous year questions, the same concepts, more than 50% concepts are repeated. That's why once we solve these questions, then whatever the question you are facing in the coming examination, you can easily tackle that question. And after that, you try to get previous year questions which are having calculation part. But my suggestion is without using the calculation. Initially, you may feel difficulty in getting the solution, but once you make them as practice, at the time of ESC examination, so you can easily solve the questions without using any calci. So my other advice is try to learn some shortcuts related to the multiplications, related to the square roots, related to the cubic roots, and related to the squares, and related to the cubes of larger numbers. So in YouTube, we are having plenty of sessions are available for us to get these short tricks. So try to go through them so that we are saving lot of time, because so in ESC maximum, if you take this one, time slot is very less for solving the problem. That's why you try to focus on this one. And in addition to that, focus on logarithmic values related to the log 2, log 3, log 5, like that. In addition to that, some basic trigonometric formulae, trigonometric identities, sine square plus cos square theta equal to, like that we are having some trigonometric basic formula is there. Try to focus on that trigonometric basic formula. If you follow these things when you are preparing this subject, then that is going to give you a lot of confidence while you are preparing for the ESC examination, right? That is only the main drawback. Calculator is not allowed in these particular examinations, and year to year calculation part is going to be increased. So student better to focus on the calculations using manual calculations instead of using calculators. And at last, when I'm talking about the reference books are basically helping us to enhance the subject skills. But from the competitive examination point, we are not suggested to take each and every subject and you try to read the reference books and getting the things. It is taking a lot of time. But being time is constraint for the examination. So try to focus, first of all, you try to focus on the classroom material and whatever the material provided by our academy, and various resources you can identify it. Try to grab the things and make it as one notebook and go through them so that you are saving the time. Somehow, suppose if you are facing any trouble related to a particular topic, at that point, at that moment, you just open the reference books and try to just get the concept from that particular book. And as far as strength of material is concerned, we are having plenty of reference books. So beautiful books are available. The reason for that is, as I told you, this is giving the platform for many of the subjects related to the design. That's why many standard books are available for us. So some of the books, if you take, the first one is the Mechanics of Materials, written by Timoshenko and Gehr, and Mechanics of Material by R.C. Hebler, and Mechanics of Materials by Andrew Peitel. So many books are available, Beer and Johnson, many books are available. So just take any one or two books for the reference purpose. As far as civil is concerned, just I am taking the Indian other books, Ramamritam, Strength of Material by Ramamritam, and Mechanics of Materials by Dr. B.C. Punmia. These are some reference books so we can keep with us to enhance the subject skills, right? See, this is the preparation strategy you need to follow. These things are very important. So if you follow this pattern, definitely your subject skills are going to be increased and you are confidently appear for your coming examinations. All the best, my dear friends. Hope you are doing well.